A planet observed crossing in front of, or transients, a low-mass star has been determined to be about the size of Jupiter. While hundreds of Jupiter-sized planets have been discovered orbiting larger Sun-like stars, it is rare to see these planets orbiting low-mass host stars, and the discovery could help astronomers to better understand how these giant planets form. This is only the fifth Jupiter-sized planet transients a low-mass star that has been observed, and the first with such a long orbital period, which makes this discovery really exciting, said Caleb Cañas, lead author of the paper and a Ph.D. student at Penn State and NASA Earth and Space Science. Originally detected by NASA's Transients Exoplanet Survey Satellite (TESS) spacecraft, astronomers characterized the planet's mass, radius, and its orbital period using the Habitable-zone Planet Finder (HPF), an astronomical spectrograph built by a Penn State team and installed on the 10 meters Hobby-Eberly. A paper describing the research appears in the September 2020 issue of the Astronomical Journal and is publicly accessible on arXiv. A transient's Jupiter-sized planet is amenable to further observations to see how well the orbit is aligned with the spin axis of the host star and to constrain how it could have formed, said Cañas. Furthermore, the low mass of the host star and the long orbital period result in a Jupiter with a moderate temperature compared to similar planets detected with NASA's Kepler Space Telescope. The host star, TOI 1899, is a low-mass M-dwarf star about 419 light-years away from Earth. The planet, TOI 1899b, is two-thirds the mass of Jupiter, 10% larger in radius than Jupiter, and is 0.16 astronomical units (O), a measure defined as the distance between the Earth and the Sun, from its host star, such that a full year on TOI 1899 takes only 29 Earth days. For comparison, the four other transients Jupiter-sized planets around comparable stars complete their orbits in less than 4 days. The planet was detected by TESS using the transit method, which searches for stars showing periodic dips in their brightness as a telltale sign of an orbiting object crossing in front of the star and blocking a portion of its light. The signal was later confirmed as a planet using precision observations from the HPF spectrograph that measure the planet's mass by analyzing how it causes its host star to the wobble. From a formation and orbital evolution perspective, there is not a clear dividing line between warm Jupiters and the large planets even closer to their host stars, the more commonly discovered hot Jupiters. Warm Jupiters like TOI 1899b orbit surprisingly close to their star, said Rebecca Dawson, assistant professor of astronomy and astrophysics at Penn State and an author of the paper. Even though the planet's orbital period is long compared to many other giant planets detected and characterized through the transit method, it still places the giant planet much closer to its star than we'd expect from classical formation theories. Detailed characterization of their physical and orbital properties, system architecture, and host stars, as the HPF team has done for TOI 1899b, allow us test theories for how giant planets can form or be displaced so close to their star. The Habitable-zone Planet Finder was delivered to TH. HPF is designed to detect and characterize planets in the habitable zone, the region around the star where a planet could sustain liquid water on its surface, around nearby M-dwarf stars, but is also capable of making sensitive measurements for planets outside the habitable zone. This warm Jupiter is a compelling target for atmospheric characterization with upcoming missions like the James Webb Space Telescope, said Suvrath Mahadevan, professor of astronomy and astrophysics at Penn State, the principal investigator of the HPF spectrograph, and an author of the paper. HPF was critical in helping us to confirm this, but detecting a second transit is important to very precisely pin down its period. In addition to data from HPF, additional data were obtained with the 3.5 meters telescope at the Kitt Peak National Observatory (KPNO) in Arizona and the 3 meters Shane telescope. Story source: materials provided by Penn State. Original written by Sam Schultes. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.